Hello, this little video is to give you an overview of the science skills that you're going to need for your assessment today. Let's start with the first one, which is the independent variable. So remember, in any investigation, this is what we decide to change on purpose. And as a result, the dependent variable will change. So I change one thing and it makes something else change as a result. The third kind of variable we're interested in are the control variables, and these are the things that we try to keep the same during the experiment in case they might affect the result. So let's have a look at an example. This is where we might be investigating how the length of a wire is going to affect the resistance. So if that's the case, then the independent variable, the thing that we are changing on purpose, is the length of the wire, and as a result, we might expect the dependent variable to change, which is the resistance. The second skill that we need to just go over is how we calculate a mean result. This is something that you've already done plenty of times in maths, but we add all the numbers together and then we divide by the number of values that we've got. So let's have a quick look at an example. If I wanted to calculate the mean of these three numbers, then I would need to add them together and I'd need to divide by 3. And if I do that in this example, I end up with the mean value, which is 2.4. Something that may be a bit new to you is how we calculate uncertainty. And this gives us an idea as to how close to the mean value our results are going to be. And to calculate uncertainty, we take the smallest value in our results from the highest value. That's after we've repeated it. So we do a number of tests, we repeat it, we take the smallest value from the highest value, and we divide what we've got by 2. So let's have an example. I want to calculate an uncertainty for these results. So there's 2.4, 2.7, 2.1. I've repeated my experiment, done 3 sets of results, and that's what I've got, and I want to find the uncertainty. So the first thing I do is I take the smallest number away from the biggest number, which gives me 0.6, and then finally I divide that by 2 to give me an uncertainty of plus or minus 0.3. So what this means is when I've calculated the mean average, so that was 2.4, then my results are going to be plus or minus 0.3 away from that value. But the main thing to remember is get the smallest value, take it from the highest value, and divide what you've got by 2. Okay, something that we'd have looked at a little bit more recently is precision. This is when the measurements in our experiments have been repeated and the results are very close together. So if I look at these two examples here, 23.2, 23.4, 23.0 are very close together. So that's a reasonably precise set of results, whereas 23.1, 28.9 and 12.3, if that's my repeats, they're not very close together at all, so they're not very precise. Going along with that is resolution. And this is the smallest change that we can measure with an instrument, or the smallest change we can detect. So if I look at the examples we've got here, the resolution of the ruler is 1 millimetre. That's the smallest measurement that I can get on my ruler. So I could measure the difference between 11 millimetres and 12 millimetres, for example. And then if I have a look at my thermometer on the right there, the resolution is 2 Celsius. So the smallest division that I can measure there is 2 Celsius. So I could measure the difference between 10 and 12 or 12 and 14. And finally, just a recap of errors. There are 2 kinds of errors. The first are what we call random errors. These are usually one-off mistakes and they only affect one result. Systematic errors are when the same mistake is made every single time, and so every single result is wrong by the same amount. So a good example is if you've got a balance and you forget to zero it, and so all the results are too high by the same amount. And a similar one might be if you're not measuring a length or an extension from 0 each time. So a common one is if we're looking at something like measuring the extension of a spring or the extension of a wire, is that we measure the length rather than the extension. So that's a very common mistake that's made. All the results then end up being too large by the same amount.